Hi, and welcome to the first video tutorial that covers modding in Project 5 Sightseer. This video will explain the process of adding new models to the game. If you have not yet read the modding guide that's available on Google Docs, it is highly advisable that you do so first before getting started with this tutorial. First, you're going to have to download Unity. Unity is the game engine that was used to make the game, and also the game engine that you will be using to make mods. We do need a specific version of Unity for the game, 565p1, and you can download it by going to this link in the modding guide. If you scroll down a little, you will find it right here. It is possible that you may want a later version, such as 566 when it comes out, and you can use that, but you cannot use anything below 565p1. Just choose the platform that you're developing it for and install Unity itself. You don't need to install any build platforms such as Linux and Windows because you will not be building for it. With Unity installed, you'll need to download the modding project itself, and it's this link, aaronmook p5s mod on GitHub. The README explains the basics, which is something that's also available on the modding guide. But the gist of it is you download the zip file of this entire project, or clone it if you're familiar with Git, and that will give you the entire project to play around with. So click the button, download as zip, extract it somewhere where you can find it, launch Unity, and open the project. If you have your own 3D models, you can actually add them to the Unity's project under the assets folder, or you can grab one of the existing projects and use them in order to follow this tutorial. Windward, for example. Just save it as a zip file, extracting it in your Unity's project, and that's it. Just make sure it's underneath the assets folder, otherwise Unity will not be able to pick it up. If you extract it here, that's not going to work. Has to be underneath the assets. And so here we are. When you launch Unity, you should be able to see what I see right now. Sightseer is the folder that contains all the files you're going to need in order to extract the mods themselves. And Windward is the example that I'm going to be using. The empty scene doesn't actually have anything other than light sources and a probe set up. Probe is actually used by the shaders in the game. So you can actually use this empty scene as a starting scene for your testing of your model. So what is the absolute minimum we need in order to add something to the game? Well, of course, let's add the model itself to the scene and get started with that. Also probably worthwhile putting some material on it. I'm not going to teach you how to use Unity. I'm going to assume you already know how to do this. If not, I would suggest watching Unity's tutorials. They're actually pretty good. For the most part, everything is just drag and drop. And there are two crates here. We probably should pick one of them and just use them as is. So here we go. This is the crate that we will be working with. We're going to add this to the game as a container object that can actually hold items. Just to keep things clean and nicely organized, let's just create an empty game object and make the crate itself a render underneath of it. We will be adding all the necessary scripts on this game object, and we'll just call it new crate. So what is actually needed to make something placeable in the game? A couple of scripts are going to be necessary, and I will explain each one of them. First thing we should probably do is add a Rigidbody, because this is going to be an actual object that will go in a game. And it's not an object that can be interacted with because, well, we want it to be stationary in this case. If you don't want an object to be stationary, then the kinematic checkbox is not going to be necessary, but I will not cover that. I'll cover that in a later tutorial, most likely. Anyway, Rigidbody with a kinematic flag checked. We're also going to need a collider in this case. we're probably going to settle with a simple box collider because it nicely covers the entire object, just to keep it simple. Of course, adding a rigid body and a collider makes it possible to interact with this game object using physics in the game, but it's not going to make it placeable. So, to make it placeable, let's start with Placeable Object. When you try to add the script, it will also add the TN object. TN object is a network communication object script that is actually used to communicate anything within the game. Sending and receiving messages, it all goes through the TN object script. So don't worry about the fact that it was added. Just know that it's needed. Placeable Object script has a whole bunch of options you can actually set if you're curious. And since they all have tooltips that explain what they actually do, I'm not going to explain them in the tutorial. One thing we probably should set is the placement box for the object itself. In this case, each one of these dots actually represents a height check when placing this object. As you can see, it is actually a lot larger than we need, so we should probably adjust it. In this case, the bounds are going to be minus 0.5, 0.5 by 0.5, 1 by 1. I think that about covers the object. Yep. One thing we should probably also do is raise the object's render itself so it actually sits neatly on top of the ground rather than being submerged halfway in it. So here we are. The placement for the object should now be okay, and the object will sit on the ground correctly. I will check the static checkbox, however, because this object will not be moving around, and as such it can be optimized and batched into fewer draw calls in order to improve performance. Right now this object can only be placed on flat surfaces, but in this case I want it to be placeable on the terrain, uneven terrain. So I will remove the flat surfaces checkbox right here. For the placement height, I'll keep it at lowest, which means that out of these 4 points that will be sampled, it'll pick the lowest terrain height and place the object at that height. Okay, let us move on. One other script you may have noticed that was automatically added along with the Placeable Object is the Outpost Object. Outpost Object is what essentially makes this object belong to an outpost. And you can actually uncheck this Allow Capture checkbox if you don't want this object to be capturable and initiate an outpost capture process. The reason we need this particular script is also because this object is colored, and faction color checkbox right here means that this object will automatically inherit the colors of the outpost. In this case, it'll be using the structure colors. We're going to actually change it to use the vehicle's colors instead. Of course, if you don't want this object to be colored using the outpost colors and just keep its own colors, simply uncheck the faction colors checkbox. Next is the Affected by Floating Origin script. And if you don't have this script attached already, you should do that by using Add Component Affected by Floating Origin. So this script is actually necessary on all objects in the game that will be either stationary or moving, such as vehicles, because as the player travels around the world actually has to be snapped at certain points around the player. And this script facilitates exactly that. I will not explain the reason behind it. Let's just say that floating point precision gets reduced quite quickly when you actually play the game without this. Also, if you did have to add the Affected by Floating Origin script manually, then you will want to reference it on the Placeable Object itself over here. Just drag and drop the object itself right into the slot, and that's it. In order for the object to actually show up on the build list, we need to add another script. This script is called Prefab Filter. So just start typing and there it is. Prefab Filter script actually lets you define filters that are essentially categories that are used in the build menu. So for example, if in this case it's actually a world container, so categories can actually be, say for example, one and say custom, and then this custom will show up in the game. But in this case we'll use two fields, world and container. Thumbnail zoom actually lets you control how close the camera is going to be when creating a preview for this object in the build list. So the lower the value, the closer the camera is going to be. Let's set it to 0.8 for example in this case, although probably a 7.5 would be even better, so 0.75. We'll see how it looks like in the game later. If you wanted this object to actually have a different preview, you could specify that here. You could also specify a preview texture if this is not model components. For example, in the case of the flare, the road flare, I actually specify a static texture instead, so because the transparent objects are not very well visible in the build menu. One other component that we really need here is the crafting requirement. This is what will actually allow us to build this object by using a specific amount of resources. So for example, here I can specify one resource, I can choose metal, and say it'll take 2000 metal in order to create this container. So the way this object is set up right now, it is possible to export it and build it in the game. But there's two things still missing from it. One is the level of detail script that will allow this object to fade as the player gets far away from it. And the second one is the actual container itself, because right now it's just a regular Outpost object, it's not a container object. But we'll get to that. First, let's add the level of detail to it. To do that, add LOD instance script, and that's it. On the render though, you will want to add something else. In this case, this render can actually be colored using Outpost colors, because it's using the color mask instead of just an albedo texture. So we could attach a faction object render, which would allow this object to be colored using the Outpost colors. However, since on the new crates, Outpost was it? Yeah, faction colors here is not checked, we will not be using this. So instead of the faction Outpost render, we'll add a LOD object script. So LOD object on the renderer and LOD instance on the root object itself. It's important to know, however, that in order to use the level of detail, you should use one of the Tasharan shaders. In this case, we're using Tasharan Advanced AO, which is the default shader that is actually used with vast majority of the objects in the game. It's also a good idea to reference the render itself. So here we got a render reference, so we can just drag and drop the object itself that has the render on it. And the instance, which is the root object, dragged over here. You don't have to specify these, they will be automatically filled out for you when the script runs, but doing it beforehand will make this object load faster. So back to the Outpost object script. Two more important fields here, title key and tooltip key. Title key is the name of the object. If you don't specify anything here, you can also check the name is localizable checkbox, which means that it will try to pull the name of the object, in this case new crate, from the localization file. Or you can specify something custom, like custom 0 for example, and custom 1. And these two strings will be pulled in from the localization file and loaded as the name of the object and as the tooltip information of the object itself. If at any point you want to replace the object type with something else, like for example here we want to replace the Outpost object with a container object. To do this, you can actually go to here, enable the debug menu, select the script, and choose a different type of a script. So container object right here. So when you actually examine the API documentation for Sightseer, you will notice that certain classes derive from other classes. Everything ultimately derives from a faction object or faction entity. And container object actually derives from the Outpost object. So since we're swapping the two scripts, it will inherit all the properties of the Outpost object and add some additional ones, like for example the capacity. At this point, once the scripts have been swapped, you can change this drop down back to the normal view, which will allow you to set up additional properties, like for example the capacity for this object. In order to specify what the container will actually hold, we'll need to do this underneath the capacity field. So you can specify power in order to store electricity, for example, but in this case we're going to start it storing gravel. And for the value, that is actually the volume in cubic decimeters. We're going to want to specify, say for example, 2000, which is 2 cubic meters worth of gravel it can fit into this container. We also need to specify that it will store liquids, or solids rather. It probably should not store liquids or gases because, let's face it, it's just a crate. And it definitely cannot store radioactive materials. But if you were making something like that, you could actually specify the pressure that the gases would be stored underneath here, how much power is used and such and so on. Again, if you're not sure about something, just hover your mouse over it and it will explain what the field actually is. So for the most part, we're actually done now, but we should probably set up a box trigger for collision during placement. And we should probably fix the box collider to actually match the dimensions. This is better. So I'm going to copy the box collider, create an empty game object, and paste the collider here. And I'm also going to change this to be a trigger instead. So the way this will work is the game will actually disable all the game object colliders and enable all the game object triggers while doing placement of the object. So when you drag it from the left-hand build menu into the world, it'll do that. And triggers are actually used to determine the collision. In this case, we want it to be possible to submerge this object in the terrain a little. So we're also gonna move the game object up a little bit and reduce the size of it, say for example to 0.5. So like this. So this will allow the game object to be partially submerged in the terrain before any kind of collision occurs, which is what I want in this case. In order to export the object, you can actually do this by simply selecting its root in the hierarchy view, going to Assets, Data Node, Export Selected, and either as text, binary, or compressed. Say, for example, I wanted to export it as compressed for the best size. In order to do this, you should also create a mod folder for your mod in Documents, Sightseer, Mods. If mods folder doesn't exist yet, you should create it. In this case, I created a simple folder inside of the Sightseer mods called new crate. And inside new crate, I will export this exactly as new crate.bytes. I will want to replace this, yes. Here we go. The final exported size for the crate is 101 kilobytes. At this point, the mod is fully usable in the game, and you can launch it and select the new crate mod, and it will show up in the build menu. If at any point you have more than one object per mod though, it's probably a good idea to save your object as prefabs by dragging them from the hierarchy view into the project view, this creates well, in Unity's terms, it's like a bundle basically. A prefab is like a bundle of an object, and you can actually instantiate multiple copies of it in the scene if you want, but we're not going to be doing this. Anyway, the idea is to create an actual folder for all your models. Say, for example, call it model, and put all your models inside this folder. And then you can simply select the root folder and do the same thing as assets, data node, export, and as whatever you want. And this will export everything inside this folder underneath your assets file. So let's try this as compressed, and there you go. You can actually see the default name of it is now assets.bytes. Also, and it is important, if you happen to have source code files, C# scripts, you should also put them underneath the folder that you're trying to export. Say, for example, I'll call it export for simplicity's sake. So everything that I would want to export will now go underneath the export file. If I wanted to export textures, for example, I would also drag and drop the textures underneath the export folder as well. So, sorry, folder, not file. And yeah, source code, textures, audio files, everything that is necessary to be exported and is loadable from the game would go underneath the export folder. And you can actually have subfolders inside of it as well. It doesn't matter. The game will automatically, well, not the game, the exporter will automatically try to find the files that are necessary. So if you happen to attach a script to your crate called My Awesome Crate, and it's not in the export folder, the exporter will find it for you because it is attached to game object, and it will export it alongside the assets file. But if a script is not referenced directly on the prefab itself, then you will have to place it in the exports folder before running the data node export. If you don't do this, then you'll have to copy the scripts manually. You can do it if you want, but this is just easier. You can actually test your exported objects without having to go to the game right here in the modding project. You can hit play in order to make sure that nothing you do will persist. Go to Assets, Data Node, and import your exported model. So here we go. Now there's a crate. You can actually examine it, and everything is as it should be. The textures themselves, they're actually coming from the file now. When you actually click on them, it doesn't highlight anything on the left-hand side because they're different textures. But if you want to double check all the properties on it, this is how you would do it. As far as I can tell, everything is perfectly fine, and I did test it in the game, and it does work. You can even test other models this way. So I'm going to delete the crate, I'm going to use data node import as well, and I'm going to go into my folder where I have all the modded exports. Here is where I exported the A0 container. When I actually import it, I'm going to get an error because there's no localization data present, but that's fine. Objects themselves are still here, and the container is still here, although it's not at 000, which is why it's not visible. Here we go, that's better. So this is a container, and the reason it actually shows up as gray is because of the shader. The shader that is on the model itself is Tasharan Structural. This shader allows the object to blend with the terrain itself. The downside of it is if there's no terrain, then it's going to show up as gray like this. So it makes it a little bit more difficult to test in a standalone project, but it will work as expected in the game itself. Anyway, point is, if at any point you want to examine an existing object from the game, you do just do this. Hit play, assets, data node, import, and import an actual .bytes object. If you don't have an example of an object that you want to examine, just ask me on Discord and I will create it for you. And that's about it. If you have any questions, again, ask me on Discord. Thanks for watching and enjoy modding Sightseer.